Well, good morning, and we welcome everyone. My name is Edwin Chavis, and I am the Small Farms Outreach Training and Technical Assistance Coordinator here at Kentucky State University. And again, we welcome each and every one of you. Today, we'll be talking about NRCS and drones. That's our topic for the day. Just some general announcements. We normally give a few announcements before we start the program. On August the 23rd at 6 p.m., we will have our beef cattle meeting at the Bluegrass Stockyard. Each and every one is cordially invited. Next month, for third Thursday, our topic will be pawpaw. So at this time, our first speaker will be Mr. Michael Zachary from Natural Resource Conservation Service, and he will be talking about climate smart programs. So let's welcome Mr. Zachary.
Good morning. Thank you, Mr. Chavis. Excited to be here on this morning to speak about NRCS programs, and so bring you greetings on behalf of our state conservationist, Ms. Joni Franklin, and the state of Kentucky NRCS. And as was stated, my name is Michael Zachary. I am the outreach coordinator for the state of Kentucky. And so basically what I do is I'm kind of like the liaison between the farmers, producers, entities, and NRCS. So kind of like the face of NRCS in the state of Kentucky. So with that, we're going to get started with the presentation. There we go. All right, so basically, not sure if you are familiar with the Inflation Reduction Act. Most people refer to it as the IRA, and this was signed into law by President Biden. And what this does, this act gave $19.5 billion of existing funds for conservation programs. And I put a form on each person's desk, each table. If there's not enough, there's some on all the other tables, so please get one and we'll talk a little bit about it. But it's a breakdown, as you can see, $8.45 billion for EQIP, $4.95 billion for RCPP, $3.25 billion for CSP, $1.4 billion in ASEP, and then another $1 billion in CTA. Now, what this does, this didn't create a different program, but it just gave additional money to the programs that we have. And this hour will run throughout September 30th of 2031. So it started this year, and it's going to go until 2031. And so what this does, it's basically dealing with climate smart programs. And so what the focus is to reduce the greenhouse gas emission, carbon, and help us deal with this climate crisis that we have. So the goal of NRCS, of course, is to support farmers, ranchers, and private forest landowners in meeting their conservation goals, regardless of the size, location, and type of your operation. And so with this IRA, that came into existence this year, it provides an opportunity for you to expand or for us to expand this operation. So $19 billion, would you agree, that's a pretty nice chunk of money for us to be able to do some conservation. This is the largest amount that we've ever been given. So how does the hour work? So basically what we do is we focus on some mitigation programs, and so there's a list of mitigation practices that we focus on, and that's basically the handout, and we'll talk about that in just a second on what the mitigations are. So as I said, it's to reduce the greenhouse gas emissions and improve carbon storage, and so we're going to talk about how you can do that and what practices that we have approved in order for you to receive our funding. So just as some examples here, you can see practice number 612, tree shrub establishment, 490, tree shrub site preparation or access control. You also see crop rotation. One of the things that most people are really familiar with is cover crops. So cover crops also falls under IRA. The irrigation water management system, pest management, conservation systems, these are all things that fall under IRA. Prescribed grazing, 528 is the practice standard. Watering facilities, stream crossing, fencing, all of these things help enable mitigation. So these can fall under that IRA practice. So what I'm saying by that is that if you have a conservation plan and any of these fall in it, you can get the IRA funding for that. So the benefits. So some of the benefits of the IRA as we're talking about this conservation is that it reduces risks and vulnerabilities by building resilience to climate change and impacts climate change to adaptation. So that's what we want to do. We want to address climate change. It also addresses other resource concerns like soil health, water quality, pollinator and wildlife habitat, and air quality. So one thing that we want to make sure that we are letting our producers know that if you don't have mitigation practice when you're trying to get some funding, if there's not a mitigation practice, then you can't get our funding. Doesn't mean that you can't get funding. It just means that if you don't have one of these our practices, then you won't get our funding with the contract that you sign. So let's talk about Kentucky for a little while. So in Kentucky, what happens is the state conservationists will decide what are the key focuses that we want to focus on. So basically, we decided 3 components that we want to look at. So number 1 was soil health, forest health, and energy conservation. So that's what's on your table right now. For those of you that are watching and viewing online, it might be a little hard to see, but I did put it in the slides. So we're going to talk about that in just a second here. So let's look at soil health. So under soil health, if you have that paper in front of you, these are all of the practices that you can see that if you have any of these, this helps with IRA. So for example, if you're doing, say, 328 conservation crop rotation, you can fall under any one of these 328A, B, E, F, G, and N. So that would help us to resource conserving crop rotation, improve resource conserving crop rotation, soil health crop rotation, modifications to improve soil health, increase soil organic matter, crop rotation on recently converted CRP grass, lagoon cover for soil organic matter, or intercropping to improve soil health. Hopefully that's making sense. So if you have one of our technicians come out and do a program or do a plan for you, and they say, okay, this is what we see, we're going to implement one of these plans or whatever, as long as you qualify for one of these or you're going to implement one of these plans, then you can get our funding under soil health. Let's look at the next one. So the next one, let's say you're interested or you have forest and you're doing a forestry plan. If you flip the page over, those of you that are here, so agroforestry, forestry, upland, and wildlife habitat. Say you want to do a riparian forest buffer, then you would fall under the 391. So if you do 391, you can do any one of those, A, B, or C. So as long as you fall in one of those practices, you can get some of this IRA money. All right. In the state of Kentucky, this year we received $2.4 million of the IRA funding, and each year is going to go up. So next year we're gonna double that. The year after that is going to go up until around 2016, 2017. We're going to hit our peak, and then we're going to start coming down that slope. And then the last one, of course, is the grazing and pasture. And if you flip your page over, you will see you can qualify for 512 or 528, and it tells you the different codes that you fall up under. So those are the IRA strategy for Kentucky. Those were the ones that we used this year for fiscal year 2023. So, as I have this next slide queued up, there is something that I do want to share. It's not on the slides, but I do want to share with those that have the paper in hand. If you don't have a paper in your hand, as I said, there are some on the tables, and I have many over there that I can give as a handout. But please turn with me to this handout. You'll see something that says IRA Equip Soil Health Fund Account Fact Sheet. Looks like this. So what we do, when you go into your service center, depending on what it is that you're trying to qualify for, whether it be soil health, forest health, or if you're doing an energy conservation, they're going to fill out this sheet. And this is how we do the ranking. So they're going to ask you these questions. And based on this questionnaire, this is how we determine whether or not you're going to qualify for IRA funding. Of course, with everything that we do, there is a ranking process. Now, one of the things that I need to make abundantly clear, what we have found out where we lose about 20% of our applicants, is that every year, beginning in October, even if you have applied the previous year, you have to come back and re-sign the eligibility form. What's happening is many of our farmers, they sign the eligibility form because we take applications all year long. So we're taking applications all year long, but in October, we move to a new fiscal year. And if you don't go back in and sign that eligibility form saying that you make less than $990,000, then when it comes time for us to give you, award your contract or whatever, we can't, because then it'll say that you're ineligible because you didn't do the eligibility form. So if there's nothing else you take from this presentation, make sure that every year, after 1 October, you go back in and you sign that eligibility form. Now, what's supposed to happen, and some of our service centers do a better job than others, is that they will contact you and they'll say, sir, ma'am, please come back in and sign your eligibility form. But if you don't get a call, just put a reminder on your phone or something and say, okay, 1 October has come. I need to go back into the office and sign my eligibility form. Please do that so that you don't get disqualified because you didn't have your eligibility form signed in. All right. So to this slide, as I said, everybody has a part to play when it comes to delivering climate-smart solutions, regardless of the size, location, or type of your operation. Now, this is not the presentation for today, but one of the things that you will hear a lot coming up is what we call urban farming or small-size farming. So we have redefine what it means to farm. There's no longer an acreage size to farming. So meaning that you can farm in your backyard. So everybody has a part to play, regardless of the size, location, or type of your operation. So if you've never applied, NRCS, we're here to help you. And if you've applied before and were not approved due to limited funding, try again. As I said, with IRA, there's $19 billion nationwide. Each state is getting a piece of the pie, and so we're trying our best to fund as many people as we can. And so what you need to do is contact your local service center. And there's pretty much a local service center in almost every county. Just go out. You can even Google it, your local service center, and go and speak with our NRCS representatives, and they can help you with this process. So what happens is each year we accept those applications. As I said, we're even accepting applications even now. But our cutoff, we normally have a cutoff time. This year, our cutoff was April. We stopped taking the cutoff date for our applications was April of 2023. And then after April, they began to rank those applications. And then around about June or so, they started letting producers know if they were awarded those contracts. They were awarded or they were funded, should I say. We'll do that same thing again. We don't have the dates just yet, but that's the way that we did it in FY23, and we will do it again in FY24. So what I want to do, there's about 2 more slides left here. Some of the other climate smart programs that are out there, we have Climate Smart Agriculture and Forestry. It's called CSAF, and this deals with nutrient management to support soil carbon monitoring, and that's the website that you can go to, farmers.gov/climate-smart. We also have NRCS Climate Change Adaptation Plan, and this deals with vulnerabilities to integrate climate change into NRCS programs, operation, and decision making. We also have the USDA Climate Hub, which develops and delivers science-based information and technologies. And then we have the partnerships for climate smart commodities. The partnerships, many of you are familiar with OAK, the Organic Association of Kentucky. They are one of our partners. They got a partnership agreement with us to do some climate smart operations. So there's also those that are available. The other one that I really want to highlight is this smart nutrient management. If you go to that website, it'll talk about that plan that you can do, the smart nutrient management plan, and it really helps you develop a comprehensive plan because we're, as it says, NRCS is streamlining using existing tools and standing up new initiatives to expand the availability of nutrient management assistance for producers for the 2023 crop year, which will also go into next year. Funding from the IRA will support producers implementing nutrient management, climate, and mitigation strategies. So once again, there's a lot that's going on with the IRA to help with climate smart projects. This is going to go on through 2031, and we hope that we can be of assistance to you. If you have not worked with NRCS, please, sir, please, ma'am, reach out to us. We're here to help. So at this time, that concludes my presentation, and I will take any questions. All right. Thank you all.
Thank you, Mr. Zachary. Our next speaker will be Mr. Jeremy Stanford. He at Kentucky State University, and he'll be talking with us about agriculture and geospectral technology. So let's give our undivided attention to Mr. Stanford.
Thank you very much. Yeah, actually, the entire show, the rest of the show is about drones. So we're going to be going over many examples, a lot of the open work that we have, a lot of the other staff that you see here. These are the folks that are conspiring with me to try to show that this stuff works or doesn't work, as the case may be. We actually have a negative reporting today. So it's just all about trying to show what you can do with the drones, how they can aid you to document and monitor the farm work or forest work that you may do. And yeah. So we'll go ahead and get into it. I'm going to give you a pretty broad explanation about, in general, what geospatial science is as an approach. And then we'll go through the examples. It's mostly pictures, so I'll be kind of passing through some of the pictures pretty fast. It's not important that you remember everything that you see, but if something speaks to you at any point as we go through here, just stop me immediately and we can discuss your idea, because that's really what we're trying to get out of here today. Is if you can see a way that the work that you're doing that can benefit from this, I would love to work with you right away. To just test that out and see if that works or not. So broadly, geospatial sciences mostly is about mapping and using sensors to try to recreate the real world, to create a digital twin, a copy of the real world in your notebook if that's what you need. But you see this all over. You have every kind of map and app to help you get to some address that you're trying to find. Or if you're trying to find information about, who owns a parcel in the city or a tract of land, all of this stuff is mapped out already and available for you. And broadly, GIS is the system that we use to integrate all that data and use it and make maps and that kind of stuff. Now, very closely connected to GIS is this approach called remote sensing. And remote sensing is essentially using sensors that capture different parts of the electromagnetic spectrum. It sounds a little complicated, but that's exactly what your camera does that you have in your pocket. You take a picture, all you're doing is basically measuring the recorded light from the surface. And that's what our drones do too. It's mostly a flying camera, but the key is that we have a lot of special fancy camera types on it. And I'm gonna be giving you some examples here. But the remote sensing has been around since like the 1960s. So you all probably know there's literally thousands of satellites just circling the Earth at all times, just looking, watching And that's how we, basically know what's been going on the surface of the earth for all this time, whether it's deforestation or sea temperatures or just whatever. They're not guessing, they're literally watching it play out in high definition. And most of the examples I'm going to give in this first presentation I'm giving, this is the drone. This is a low-cost, well, semi-low-cost entry-level drone, but it's advanced multispectral sensors. And I'm gonna show you some examples of what that can do. Now, this also has a camera, regular RGB camera, just like the one that's in your phone. But the real money is in those little sensors that are across the top there. Those are wavelengths of light that your eye cannot see, but it tells us a lot about what's going on with the vegetation. So in the top right, that's a regular natural color image that looks exactly like the iPhone in your pocket would take. The image just below that is actually a near infrared image. So this is light that's very important, but your eye simply cannot see it. So when you're looking outside, you don't see that. So here, we actually call this a false color composite. So the variation is true, but in terms of what it really looks like, that's not 100% accurate because, again, this is a color that you can't actually see. But it plays a big part in interacting with plant tissue, and a sick versus a healthy plant will interact very differently with this light, and that's kind of the trick to making this thing work. Oh, key part here. This diagram on the left, again, I debated to even put it in here, but basically this is the curve that describes all of the energy that comes from the sun. Okay, so all the light that's available for plants to do photosynthesis, this is how it's distributed. And only that little rainbow section in there are your eyes visible to, but look how much energy is outside of that visible range. And some of the advanced drones I'm going to be showing you have sensors that are spread out through that part of the spectrum that you can't see. So every time your drone or your phone takes a picture, you actually have a sensor in there that's taking multiple pictures in multiple different colors. So pretty much every image that your phone takes, a natural earth image, the sensor is actually designed to take 3 separate images, one in red, one in green, one in blue. And it's actually when it puts those together that it forms the image that you're used to seeing. And then that's just put up against the in out. I can also see these other wavelengths, and you can feed them into kind of whatever display color that you want. So the blue's not really meaningful here, but the variation from dark to bright is indicating high or low reflections of that invisible energy. And what we can do with that, I'm going to show you just a little bit. So if your camera has 3 bands, and I have this special drone here today that has 5 bands. On Friday, we're taking a new drone that has about 250 bands. So there's that whole spectrum. They're all important for different in different contexts. All right. So you may be asking yourself, well, why do you need so many bands? Why is it necessary to have 250 different colors? And the reason's pretty simple. Again, on the left-hand side, you have your visible portion of the spectrum. And these curves that are represented here, depending on what species of plant it is, different species of plant have different organs inside of them that are designed to absorb light in different parts of the spectrum. So as a rule, blue and red energies are consumed by plants for photosynthesis, okay? But depending on what kind of plant it is, C3 versus C4, or where in the geography of the world it's growing, it may be specialized because of the conditions to absorb light in different parts of the spectrum. So imagine like a snowy mountain peak in an alpine part of the world versus a tropical forest. The lighting conditions are very, very different. Therefore, the plant receptor organelles have to be different in order to do photosynthesis. So if the lights are sensitive to all of these different wavelengths, we have to be able to cover that to be able to see what's going on with the plant. And this is just a little cross-section of the plant that's showing you how different parts of the plant will be transparent or opaque to these different wavelengths of light. And when you look out and you see a healthy field in the summer, what color generally will it be? Yeah, green. Why is it green? Because the red and the blue is being absorbed into the plant for photosynthesis. So only the green light remains, and that's what goes back to the eye or to the sensor to be recorded. But as the plant begins to die, right, the growing season's over, you start mixing that blue and red back in with the green, and if anybody ever finger paint, you know that starts to turn into brown. And when the grass dies outside, that's generally what color it is, right? So it makes a lot of sense, but these are just the rules that kind of govern why that is, all right? And we can simply measure the proportion of light that's being used for photosynthesis, and we create this simple little index with it. High index, healthy, vigorous, lots of photosynthesis. Low value means none of the red light's being absorbed for photosynthesis. So we can measure pretty precisely in relative terms how much photosynthesis is happening. Now, they've been doing this for the whole world since the 60s, okay? And this is just a time lapse showing 1 year of the greening up and the greening down of the vegetation on the earth. Using basically this principles that I just described. This is just kind of a cool image to show if you're trying to understand photosynthesis on the whole globe, this is the kind of data set that you would look. And the cool thing to point out here is look at all that green that's actually in the ocean. So most of the oxygen that we're breathing today, that's where it's generated, not the Amazon, all right? Not the Amazon. It does produce a lot of oxygen there, but there's so much decomposition happening that it essentially is consuming all the oxygen that's created there. The ocean is where it's at because dead things are falling, down to the bottom, and there is no oxygen being consumed as part of that decomposition. Newer satellites can see at this fine scale. So imagine you wanted to track the productivity of every agricultural field in the county. Okay, there's a satellite system that it has a revisit time of about 3 days anywhere in the globe. So all season long, for basically anywhere in the world, we could watch every field in the county, right? So that variation in green, this is one of those vegetation index. So where you see dark green, that's heavy, full, lots of photosynthesis happening. So it's a good, healthy, thick crop. And then where it's obviously a lot lighter, it's either no vegetation because it's recently plowed or it's very early in the growing season. But as that, as the crop matures, this index essentially would track it. So as it's getting older and doing more photosynthesis because it's more leaf area, for example, that index will basically track that. So we have this numeric measure where we can, assign relative productivity levels. And the drone now allows us to just do this very same thing, but in super, super high definition. So before, we was looking at 250 meter per pixel, and then we looked at 30 meters a pixel, and then like down here, we're infinitely, infinitely small, right? Sub-centimeter per pixel, just as high resolution an image as could possibly be made. And we use all this information to try to help the farmer understand what's going on in the field. Whether or not you need to apply more fertilizer, where are the most productive parts versus the least productive parts of the field. This, can be ascertained in just one flight. And it's important to keep up with that because like in a browsing situation, what you're growing in the field is, the feed that you're giving to the animals. So that's the case to be made for why you would want to track the productivity of your field. So just give you an idea of what this looks like. So when we bring the drone to a new site, it's very easy. We simply have little apps. We just draw a square around the farm. And just as the picture shows here, the drone just kind of tracks back and forth at whatever angle, taking lots of pictures that are overlapping, and the software would just stitch all that together. You're probably very familiar with like panoramics that your phone will do. Imagine then a panoramic where it does it kind of all the way around. It's actually called photogrammetry. But it will stitch that together and make an orthomosaic, which is what Google Earth is. But it's also derived the 3D nature of the land under it. And I'll give you a little closer to that. So all green field, right? All green field, pretty healthy, pretty grass. But if I group the pixels according to their spectral similarities, meaning all of that is green grass, okay? But the color here where they're grouped together, because they have similar spectral properties, that means they're absorbing light in the same wavelengths at the same rate. And you remember I showed you the picture earlier that showed you different plants are sensitive to different parts of the electromagnetic spectrum. So this variation of color that you see, where you have pixels of the same color, they have precisely the same spectral properties because they're exactly the same species. Green grass here, green grass B, they're going to look the same, but if they're different species, they're interacting with light a little different. So what used to be all green grass, when I show it to you in this way, you actually see 50 or 60 very uniquely different interactions with sunlight. So this is how I can map out and give you an idea of what the distributions of each of those particular types of grass are. So the browsing people back here with the goats and stuff, they have been managing for years the particular distribution of grasses within their fields. Some of these grasses are less nutritious, so they're trying to get rid of them. Some of them, you know, are like the holy grail of browsing, and they want to increase those. So this is a way of tracking that over time as they do their different browse rotations, or they spray chemical, or they put new seed, or whatever. Here, this is how we track what the impact is over time. And just to highlight again, the different colors, it's all grass, but because they're interacting with light differently in that little map, the color seems real different. But if you go out into the field and identify what these colors are, those pictures, that's what you're doing, right? The blues are that, these little greens or whatever, or this, right? You see this ground truthing. And once you've provided this information to the computer, this is like machine learning. You've trained it. You've trained the computer to identify what this is. So when it sees it again, it will recognize it as what you labeled it. That is the thing right there. That's how you take pictures. Whoever's in charge of the site then has to label the imagery to tell us what it is. And then that's how we know next time that we see it. And that's kind of the theme that's going to play out over and over for the rest of these examples that I'm going to show you. All right, so how is it useful? Very quickly, say I fly 2 times, once in June and then again in August, and we want to know how much more productive are my different plots. So some of these are hemp, some of these are soy, some of these are corn, but the idea was what is the change in productivity over 1 month time? So you fly time 1, time 2, and you simply map out what the difference is, right? So if you have 2 varieties of hemp and you want to know just which one gets more mature faster, this is measuring that directly, right? Or if it's not by the plot, right? Here you can actually see the change for each individual crop, if it were important for you to keep information at that fine of a scale. And you do exactly the same thing, so instead of looking at photosynthesis levels, you can simply extract out the height. So if we're talking about pasture and you want a good idea of how much mass is out there, you simply just kind of need to know the height. That can be easily extracted from here, you know, basically for the whole thing. And again, you just take the difference between the 2 times, and there on the far right, you have a map that shows you what the rate of growth was for that 1 month. All right, so all of these projects Well, a lot of them are research-based, but a lot of these we're also using as opportunities to get students involved in agricultural type work. So the benefit of bringing the drones to the farmers to let them get a good idea of what they can do is we can also involve the students, and the students are learning more about the technology and whatever's going on out at the ag place. All right, so this will bring us to the end of the first one, and then the next three presentations will be examples of utilizing this kind of technology, but in very specific contexts. So that's it for this one. Any questions about what we covered thus far? Not yet. All right, good. All right, you ready? All right, well, stepping up for the aquaculture part of it. This is Miss Chelsea Walling. Well, you just do your thing, and I'm going to jump in
Okay.
right behind you.
Hello, good morning, everyone. My name is Chelsea Walling. I'm an aquaculture research and extension associate here at Kentucky State University. And I'm here to discuss the use of multispectral drone systems to monitor water and culture conditions at the KSU Aquaculture Research Center. So just a little background information for those that may not know. Aquaculture is the farming of fish and aquatic products. It is the fastest growing food producing sector, with more than 50% of all seafood products coming from aquaculture. This is a beautiful drone shot of our KSU Aquaculture Research Center here in Frankfort, Kentucky. And it has been offering a master's in aquaculture and aquatic science since 1999. And we rank in the top 5 aquaculture programs nationally. Some of the species that we look at are largemouth bass, paddlefish, catfish, koi, tilapia, trout, and marine shrimp. So I was asked to discuss how drones may be utilized in aquaculture. And they can be used to assist aquaculture farmers with best management practices and efficient aquatic animal husbandry. Some parameters that can be assessed by drones are water color. So we discussed the coloration of water and how that can be observed. And for aquaculture, we love to determine whether we have a harmful algal bloom. Sometimes it's not easy to see on the pond banks, but if we have a drone shot, we can see if there's a harmful algal bloom or invasive aquatic weeds that we need to manage. And we can also use that to determine if there's enough beneficial phytoplankton. So we have a lot of fish, like paddlefish, for example, that are phytoplankton eaters, and it would be good to be able to assess the quality of our phytoplankton blooms. Aeration is super important in aquaculture, and the placement of those aerators is essential to have adequate and effective water movement for things such as pad wheel placement and monitoring flow and sludge accumulation. Drones can also be used to inspect aquaculture pond sites, to check on equipment like net pins for damages, determine if ponds need repairs, overall landscape topography, and selecting sites in terms of variables like floodplains and natural water sources. And we can also utilize drones to help us to determine average surface area of ponds, which is necessary when we're doing things like aquatic weed herbicide spraying. The animal husbandry is obviously one of the most important components of aquaculture, and we can use drones to help us visualize accurate satiation feeding for fish. And we can also determine if fish are stressed or ill, because when fish are near the surfaces, that often lets us know that there might be diminished water quality. Perhaps those fish are not being fed enough and they're hungry, so they're hanging on the pond banks or near the surface. If we have a die-off, especially in large production facilities, maybe they could better visualize a die-off in a pond. We also must place our spawning mats in certain locations for fish that are spawning, and we can determine overall fish behaviors. So look at things like aggression, or just if they're not, acting right, those drones can be utilized to help us assess that. We can also have the potential to use drones to scare away nuisance species. I know us at the Aquaculture Research Center, we are not friends of sandhill cranes. They really stand on the pond banks, and especially those fish that are on the nest. They will poke and stab our fish and cause them to have illness and sickness. Things like vultures and geese, they can transmit disease, and so perhaps we can use those drones as a efficient and effective way to scare those birds away. So this is just a skimming of the surface, pun intended, for the applications to use of drones in aquaculture. I haven't personally got to really dive into aquaculture drone use, but there is a ton of information out there available, and especially with new technologies involving underwater drones and remote sensing. I've seen a lot of giant ocean net pen cultures that have underwater drones that are constantly monitoring their fish, and sensors that are submitting that water quality data to a cloud storage that is really, really effective for large-scale aquaculture producers. And as with any type of farming, aquaculture must remain at the cutting edge to increase profits and further advancements in the industry, and drones have the potential to make data collection and fish health much easier to manage. Thank you so much. This is a nice image of the Aquaculture Research Center ponds, and I think Jeremy has some more information that he'd like to add on this, but as you can see, these ponds, the coloration's different, and not only is that because of the phytoplankton blooms and the potential for aquatic weeds, but it's also determined by the species that are within the ponds. Koi fish, for example, are bottom feeders, so they're always stirring up the pond bottoms and making the water very muddy and turbid. So we can also look to assess many different parameters in aquaculture through the use of drones. Thank you so much.
Yeah, these last couple slides here, just carry on from what you said. So just a few weeks ago, they have a really awesome student group over at her camp. A lot of grad students and undergraduates always working together, always interested in the newest stuff. So we did an experiment. They are regularly collecting, I don't even know what all kind of information, but we wanted to just test, I think it was mostly just water clarity kind of metrics. She can let us know in a second. But we wanted to see how well, because you can see the variation of the color, the variation of color of the water indicates very clear variation in condition of the water. This is another kind of spectral curve that I saw you. The different constituents that make up the water in the pond, okay? Mostly you have water, you have the vegetation, you have sediment in there. If you think of those individually, they all have very different ways that they interact with light. I mean, as a rule, this is defined by physics, okay? So if you see sediment, where it's up high because it easily reflects all of that energy to a large degree. But water itself, for example, likes to absorb a lot of the stuff. So it's easy to tell the individual components. So when you look across at all the water, the variation that you see here in this near-infrared image, we know that good clean, well, not good clean water, but water with no constituents in it does a really good job of absorbing this kind of energy. So I'm not going to say it's the cleanest, but the water with the less sediment in it here are the darkest pools. So if it's only sediment that you're worried about, this is how you can measure it. And in the wild, sediment in the water is the #1 water quality issue. So they have been for 50 years monitoring big bodies of water just like this, different seas, Chesapeake Bay, whatever. But they're big bodies of water using satellite data. What's new is that the availability of high definition drones. This is the vegetation index. So in the water, certainly if you have anything doing photosynthesis, you 100% know what it is floating on top of the water. And as she mentioned, that isn't an indication that the water is of lower quality. It just means that whatever's going on in the water, and in this case, the life cycle of koi, changes the conditions of the water. So for us, we may not really know what's the desirable thing here, but we can identify what's in the water. And then it's on the people at the site to label whether it's good, bad, desirable, or what have you. But as these conditions change, they're easy to track, right? And this is just showing how we're just aggregating it to the plot. So let me just look. This is one of the plots that has koi. It's very dark. There's almost no sediment in it. And each of the different metrics, those little histograms that you see over there, essentially every pixel has a value, and that's what's making the image. So in that chart, you're just seeing the distribution of it. A clean dark water looks in that way, but a tank that has considerably more sediment, considerably more vegetation floating on the top, different water color, just looks so different. So different. Like here with the dark clean water, it's a very tight value distribution, but where you have a lot of things going on there with the pond, it basically shows up then in the number distribution. So that's kind of the statistical representation describing those. But again, in terms of what's good and what's bad here isn't being identified at all. But the conditions of the pond for her, this is a way to track that over time. So if they add more fish or change the food or do anything different in their management strategies, you would expect in some way that would show up in the habitat where they live. So that's the value that drones are bringing to that. And we even ran some tests. So they have a lot of different metrics that they're collecting at each pond. And we wanted to compare the metrics we could derive from our remote sensing imagery and compare it to what they were collecting, and it didn't turn out great. It didn't turn out great yet. Because you got to think, here I'm imaging the entire square area of the pond, but a lot of when you take water samples, maybe you're just measuring one spot of the pond, right? You couldn't expect, though, that same measurement would be equal all throughout the area because the conditions change throughout the pond, and that's what we're trying to get at. So how best to do that, this is what we're in the process of trying to learn now. So we have to honor what they have been doing for 20 years, but then clearly there's more information being left on the table. And that's all we've claimed up to this point. And an acknowledgement that we couldn't recreate the variation in their water quality data. All right, so this should translate at some point into pond management, all right? So that what we could learn here, we should be able to, use it on a lot more farm properties, with their pond water. So any questions for Chelsea regarding aquaculture, or any questions about this little experiment that I showed? Okay. Well, I think this one's me too. Oh, please, yes.
Okay, thank you so much for the presentation. I would like to know, as regards if drones can be used on field, for instance, for compliance to use of some chemicals and stuffs. Is it possible? Does it have the capability to register some probably reflectance of chemicals used on some crops, maybe that against regulations and that is for your...
That's the idea. So if you look in the literature, everything I'm talking about, none of this stuff is stuff we invented. This is since 1960s. This has been in the books. Okay, this is what we're teaching undergraduates today to do this. The key, I don't know about this particular thing that you asked about. There may be some literature already that speaks directly to that, but for brand new things, if if I could just go back to this. Here in this plot, we were able to create these metrics that describe the variation in the whole pond, with no idea how aquaculture may have felt about that. But in parallel, they are taking measurements that are meaningful for them, that are proven and tried and true, that are meaningful enough for them. They're keeping the fish alive, and they're going about the business, right? So it's clearly it's right? But there's not literature that says how the remote sensing metrics should interact with the measurements that they're taking. So we're in an experimental way trying to derive that. So for your question, if there's a new model that you're trying to create somewhere out here in the farm, we just need to fly the farm, and you will take your measurements out of the field, and we'll create a model that speaks to that. Jacob, in a second, is going to describe a project he's doing exactly like that. At 1:30, Dr. Chilyawal will be here. He has that stuff right out here in the front. He's doing precisely that too. He's taking a bunch of ground-type measurements that describe how well his crop's doing, but it's taking him all day, right, to take one set of measurements. In 10 minutes, we can fly the whole farm and have those same measurements. Will it then provide him the same information that his field measurements are getting? We don't know yet. Probably not. In fact, I know it's no. The answer no is right now. But we're trying to move closer to that. Did that kind of answer the question you're asking? Thank you very much for throwing that out. Any others? All right, based on what you've heard so far, do you think this is kind of useful for you, or could be, even if we haven't talked about your problem yet? These guys in the middle, are you impressed at all by what you see so far? Does it seem like it's even handy at all? Perhaps? All right. That's all right. That's why we put a bunch of presentations up today so we could cover the whole field. Thank you, Chelsea. All right, so the next presentation we're going to look at, this is assessment of woodland characteristics using LiDAR technology. Slightly different technology, but still drone-based. So this is woodland, and the project that I'm going to tell you about that this falls under. There's a group in Franklin County called the Invasives Partnership of Franklin County, and they are concerned with the public spaces here, mostly parks, a sculpture park, and some other kind of shared spaces. And all of these places are really being overrun with invasive species, especially bush honeysuckle. So anywhere you start disturbing, bush honeysuckle moves in. This group, this partnership, their goal is essentially to eradicate all the invasive species from all the park areas. So a lot of what we're doing is trying to provide drone information to help them do that. So there's kind of multiple stages of it. You would first need to ascertain what the extent of invasive species is first, and then describe the forest in such a way so that they could come up with a good plan for how to tackle that, okay? But it takes a long time to walk through the woods and see what all's there, okay? So let me catch the story up a little bit. Once you've decided that you have to intervene and remove invasive species, there's a lot of different ways to go about it depending on what level of infestation, you're at. At the earliest stages, you just have a couple, you can go in there with hand tools and just start ripping this stuff out, right? If there's a little more, maybe you need chainsaws. Maybe you need a group of folks with you, right? The bigger the infestation, the bigger the effort to go in after it. Another strategy we've been helping a lot of people look is turn, you fence in the area, you turn goats loose out on it, and they'll eat the leaves off of that stuff. For bigger problems, you actually have to run through with chainsaws. You have to cut this stuff and apply some herbicide directly to the tree to kill it. And then in a worst case scenario, you actually have to have this Fecon machine to actually go in there and just lawn mow the whole thing and just kind of start for new. So before they get into these projects, it's important for any new forest that they go to, they need to know what the level of infestation is for all different parts of the forest, so they can decide which of those strategies they're gonna implement. And even more than that, it's not just deciding the strategy, it's deciding how much of each strategy and at what rate, how much it's all gonna cost, and there's just a whole bunch of math that all has to go into this. And it's all predicated on what the foresters are able to find when they go and investigate the field. Basically walking around for 3 days, just seeing what's all there, taking all manner of notes. All right, and we have a bunch of drones that are capable of collecting LiDAR data. And LiDAR data is just, it's just a point cloud that represents the world. Now I'll show you here in a second what that looks like. That on the far right is a LiDAR point cloud taken from the ground. Okay, so you can see, this is leaf-off conditions, so this is like winter time. And can you see everything that's in the forest? Everything that's in this area, you see it. You see what's on the ground, you can make out the ground, you see the tree stems, you see the branches, you can see everything, right? So if you wanted a count of trees that you have, boom, there it is, all right, one flight. And the lighting's not as good, but this is like looking at the whole forest. So here is 50 billion little dots, but when taken in context, they make the entire three-dimensional structure of the forest. You have a perfect digital replica of the forest on your machine, okay? Now that's kind of zoomed in and showing you what it looks like. So you have the ground very perfectly measured for you, and you can turn that into this nice, we call it terrain model that shows exactly how the land lays. You can see where all your water would flow and all that kind of stuff. But more importantly, you can, you know, if it were grass, you could see exactly how tall the grass is and what's in it. But in this forest case, you can see the trees, and you can see all the understuff growing in the bottom. That understuff growing in the bottom, those are your invasive species. So if I just kind of zoom in into one little bitty point, that's a little 60 by 60 foot section of forest, and you kind of got a couple trees in there, and you have, you know, the under stuff, which is mostly bush honeysuckle here, and we have all these metrics that statistically define what you see there. Many different ways of statistically saying how much bushy stuff in the lower 6 feet, how tall the trees, how thick and bushy is the canopy. There's just all these really old forestry metrics that describe the forest. And we have programmed, well, we made a program that would generate these metrics from that LiDAR. Okay, and I can even pull away the top part of the forest, because I'm actually interested in seeing the infestation that's on the forest floor. That's where the invasive species are. So I can pull away the canopy top and only be left looking at what's growing up in the bottom. That's the power of LiDAR. And I can use it to make a map, essentially show you where every single tree is. So here I didn't provide the number, but you know, these are discrete trees. Okay, and that's every tree is marked and identified here. And then here's a map showing only the understory. Okay, so that's the canopy as you would see it from the sky or in Google Earth, almost total closure. But here's the amount of the stuff that's growing in the bottom 6 feet. I can see under that. On Google Earth, you don't even get to see that, but the LiDAR penetrates through the canopy. It doesn't penetrate perfectly, but I get enough of a look down there that I can see what's there. So this really is the map then, when they're making the plan to go take out the invasive species, here's a map of the enemy. This is where you need to put your effort. You can see where it's wide open under the tree canopy, right? That's where you have all that white space. That means you're walking under the trees and there's just these huge gaps, these huge alleys, you know? But, you know, down here in the bottom left or there in kind of your central right, it's just so full you cannot even walk through it. And has anybody been to Cove Springs Park? So you would recognize then, you see, he says it's a perfect representation of what he's seen there. But anyway, this is the map that they're using now. So remember before I was telling you about strategies. They had already walked around the forest before we made these maps. And they decided already that the forest fits the profile that's best for me doing cut stump here. The green area, or the yellow area, is the definition where I can just go in and take it out by hand. The blue is where I need the FECON machine, something like that, right? Forgot to put all this in here. Just wanted to show this. On the left side, those are the initial map that they gave us, the initial map that they gave us. And it's simple. It's really simple. After I fed all this information into our program, the new map it spit out is the one on the right. And it's 75% matches. So the software sees pretty much the story they were trying to tell. But imagine yourself walking through the forest making these zones. You're making a lot of compromises. You don't want to have too many small discontinuous zones, so you're not making them. You're grouping as large of an area together as possible because you're walking through the forest. You're looking. You're probably not even seeing everything. So because the computer-generated zone map looks a little different, is probably an indication that it's just picking up more on some of those attributes of the different zones. So where here, on the left-hand side, that's more for convenience. It is telling a story, but it's simplified. I would argue that the machine learning generated zone map is one that honors precisely the attributes in the field. So it's almost a disagreement in some way, right? Almost a disagreement. But the point here is this. Now they can give us a new forest that nobody's ever been to, but I already have the model built. I can create that map for a forest I've never seen, right? Nobody has to go in it. So the better they can refine this model, you know, the idea is later is that they wouldn't have to spend any of those days walking around the forest. They would just apply this model based on what they've learned so far. That's the idea behind machine learning. All right, so you would walk your way up. So in your case, on the farm, yours, you know, would have more, well, in principle, still the same, just looking at distribution of attributes, but in terms of mapping exactly the classes. Yeah, I probably don't need to labor that one too hard. But I'll just go back here. This is just another part of that point cloud, and because we're always trying to get young people more and more involved in doing this kind of stuff. The point cloud leads to kind of this Minecraft Roblox thing. So if you have young people in your house, they definitely know about Roblox, and if they're not too old, they probably know about Minecraft either. I don't know, it's hard to keep up, but it's the wildest thing. But Minecraft is just like an extreme simplification of a LiDAR point cloud. And in fact, there's software where you can create the real world in LiDAR and then summarize it into this Minecraft format and put it in the game. So, you know, your real farm could be in the Minecraft server. That sounds awesome, right? That sounds awesome. There's a few people in the state who do this, like as a hobby, okay? Melissa Miracle is the one. As far as I know, she's the only one that's actually really done this all the way. But for me, this is one of the most exciting possibilities because a map is one thing, but if you're trying to inspire 1,000 young people to get into this kind of thing, man, what's cooler than walking around with their friends in Roblox and, you know, I don't know, oh, the tree, I know that tree. All right, it would just be cool, right? It would be cool. And I just won't go over these, but I guess the point here is that statistically, we define these metrics that describe what the forest looks like, and as the condition of the forest changes over time, we have these little statistical tricks that will just track that. And the one example I can give you right here, at Iroquois Park, they have forest structure very similar to this, and it's undergrown with a lot of different invasive species, and we've roped it off and put a bunch of goats in there, and the goats are constantly eating down the interior of that, and we're just we fly it every couple of weeks to try to get an idea of the rate at which they're removing stuff from the forest. So that's kind of fun, but again, maybe not all that informative. So a lot of this stuff is also tied to grants. We get a lot of funding from the USDA to both try to help people, the researchers that are here on the farm, but also, probably more importantly, providing the opportunities for the young people to get involved with this, whether it be through our summer camps, or we have a lot of student workers as well who are kind of learning by doing in this way. So for you scientists that are here, if any of these things you want to try out, we would love to fly your area and generate these same metrics and try to compare it to the data you're collecting. Any questions? So for the forest people, did any of that seem like it would be useful for mapping out what you have? Even if it's not a research question yet, just saying what's out there, right, is the first start. And we have those metrics. And then whatever it is that you're trying to do, if it's something that's going to alter the structure of the forest, you do that over time, and you track how the forest is responding to what you do. It takes a lot longer, obviously, a lot longer than ag stuff takes, right? Because the forest takes a lot longer to do its thing than the crops. But all right, any other questions, comments? In case you was here, I was just going to mention we do a lot of this work out in East Kentucky on East Kentucky mine sites, where it's areas that were formerly mountaintop removal, and 80s or 90s, a lot of that activity ceased here, and they try to put the mountain back as best they can and growing forest back. And we're out there over time. Every couple of months, we go out to these mine sites and fly, and we're tracking the vegetation as it grows back slowly from that rebuilt environment that they had. So we're interested in over 20 years for this kind of a setup. At what rate could we expect the vegetation to grow back, and what kind of vegetation will it be? So if anybody's interested in mine sites, East Kentucky type stuff, we'd love to involve you in that. All right, so before lunch, we have our last example before lunch. We got Jacob Brown. He has these plots that are over here on the back side, and he's going to share about what his project is doing, and then I'll show you what some of his data is.
I have to correct Jeremy. Earlier he said the rest of it is about drones. That is entirely not correct. I'm going to talk about soil and then make a connection to drones. My name is Jacob Brown. Let me click forward. I am a research associate for K-State here. I've been in this position just about 1.5 years now, and we focus in soil, but we do a lot of different things. And I wanted to introduce our team before I began. I work for Dr. Gabriel Medin. He is the professor of soil science here at K-State. And myself, I'm the research associate. So when Dr. G gets different ideas, I'm the guy that goes outside and puts them into practice. And then we have 2 new graduate students that got here in January. This is Ganga Padel and Ife Familisu. Ife is right over here. He came to watch today. And we're going to talk a little bit about both of their researches. But I wanted to begin by saying this realization that I came to about 6 or 8 months ago, that no matter what you do, there's always a what you do and a why you do it, especially in research, environmental research. This soil science is our what, but this is our why. And this is what gets me out of bed every morning and keeps me going and gets me out here presenting to you all, because it bothers me and I want to improve it and I want to help you improve it. It says 34% of all agricultural land is degraded. And then if you ever hear a scientist or any corporation or somebody talking about climate change, especially climate change, they use the number 2050 to talk about it. If we don't do this by 2050, this is going to happen. 2050 is always the roundabout number that they're comparing it to, and they say that 90% could be degraded by 2050. That means that we have to mitigate it, we have to manage it by 2050, or things are going to get pretty bad. This is an estimated 75 billion metric tons. I know that's a big number to think about. If you want another way to think about it, it is the size of the state of Rhode Island twice, 5 inches deep. That's a lot of soil every year that we can't produce crops on, or that we can't produce crops on to the potential that we could. So we're going to talk about some practices, some better practices, agriculture practices that a lot of you probably know about, but we put in practice that can help your soil increase your organic matter. These are cover crop and crop rotation, reduced or especially no tillage. And one thing that we focus on is biochar application. I don't know who's heard of biochar, but I'm the biochar guy here. And it is essentially just granulated carbon. You want to increase your organic matter, but organic matter is the same thing as soil organic carbon in your soil. 58% of all organic matter in your soil is strictly carbon. So when you have this stuff called biochar, you take a feedstock. In our example, it is yellow pine. They take yellow pine that is waste wood, and they stick it in an incinerator. It's called pyrolysis. Well, that's how ours is made. That's how the majority of it is made. They stick it in this incinerator, they close the door, and there's little to no oxygen, and they heat it to incredible temperatures. And it comes out as granulated, sometimes liquid carbon called biochar. Ours was heated to about 700 degrees. If you look at the top right picture up there, your feedstock and your temperature that you produce this biochar on affects the porosity of your biochar. So although it increases your soil organic carbon, we're also looking at how much water it can help hold in your soil. The porosity in it almost makes it act like a sponge in your soil, and it holds water like crazy. You can walk out in our field right now, and if anybody wants to go see our field at any point today, I would love to take you out there. But where our biochar is, I can promise you, even in drought situations, it's more moist than it would be without biochar. In my research went from January 2020 to 2022. We applied it on October 9th, and this is the time where I believe we really started the research. Although I started in January, I think on October 9th, that's when we officially started. Give me 1 second. So this is my research. Officially, I've handed it off to Gonga now, and she has taken it over, and we'll talk about that here in a second. But we used 8 blocks in randomized split plot design. I know for farmers and producers that doesn't mean a whole lot. Essentially what that means is we can do 2 different things in the same area. So in our whole plot treatment is either tillage or no-till. Then within inside of our plot, we have different soil amendments. So our soil amendments, including the control, are biochar used alone, biochar plus cover crop, and cover crop alone. And compared or used with and without tillage, we wanted to see what it did to soil chemical nutrients. And that's organic matter, organic carbon, nitrogen, phosphorus, potassium. And then a couple of your micronutrients, we did magnesium and calcium. And it is still in this experimental design. Although Gonga is doing different things out there, we are still using that same experimental design. So I mentioned a second ago that we use cover crops. I wasn't a big drone guy when I started. I wish I was, because drones can tell you a lot more than you can learn just being on the ground. I'm a look down, get in the dirt kind of guy, get in the soil type of guy. And this is the first picture that was ever taken with the drone of my fields. And you can see our cover crop plots. You can kind of imagine how it's laid out there. And you can also see the variation and how the cover crops are growing at this point during the year. In the spring, they were, I call it terminated, because we don't harvest it and move it to a different place. We leave it in the same place. In the bottom right picture, you see the mulch that is made from these cover crops being mowed down with the flail mower. This is one of the best things that you can do for your soil as far as organic matter goes, because it almost makes like a carpet. It's 2 or 3 inches thick. You do it year over year. You almost never see your soil again unless you're tilling. This happened in October and November, both years I was doing the research. So this is the one thing I don't like to do, but in environmental research, we have to compare it. We have to do both things. So we tilled half of our plots. If you think back to the experimental design that I showed you a second ago, this is the left side, and then the right side we didn't till. We didn't do super deep tillage. We didn't do moldboard plowing, which is good. We did reduce tillage, but we still had to tear it up a little bit. The picture on your right shows you, even after you disc 4 times, that your soil structure is just completely messed up. It's never gonna be the same, and if you do it year after year, then it's never gonna hold the same amount of water. You're gonna lose organic matter. And we have some results to show how it affects what, and year after year, I promise you'll get a negative effect on most things. I know a lot of farmers and producers, you have to dump fertilizers on your soil, but you can kind of counteract that and save yourself money by just not tilling. So I'm giving you the Cliff Notes version, the short version of the results and of the total study. If you have any more questions or you want to catch me outside, ask me, because there's more data than what I'm showing you here. I knew I was right before lunch and I didn't want to hold you up. And Dr. Chilliwaw this afternoon will also be talking about some of the soybeans on my plots. So the top 2 graphs here show you what's happening inside of the plots. And these were the 2 significant differences that we saw. So we saw a significant difference on soil organic carbon, and then we also saw a significant difference on potassium levels. Organic carbon is your top left there. So between all of these things, when you run your analysis, it says, hey, you have a significant difference. And then you run a test to say, where is my significant difference? In both of the cases, the difference was between the biochar plots and the control. So if you're not doing anything, you have lower levels of organic carbon and lower levels of potassium. And in the biochar alone plots, it was significantly higher, which kind of makes sense in your organic carbon because you're dumping straight carbon on your soil, but it's interesting that you don't see it in the biochar plus cover crop plots. I would like to have seen that. And then if you come down to the bottom, you see tillage and no-till in the bottom left. And I kind of wish this was opposite, but you never know what you're going to get in research. Our tillage plots had significantly higher calcium levels compared to no-till, which there's always a why. I still haven't figured out why that happened, but it happened and there it is. And then in our corn yield, we did see a difference. We saw pretty big differences. None of them were significant. But I'm going to talk about how you can take these differences that you saw with the drones, and if you apply them over hundreds or thousands of acres, especially in these big farms in Iowa or somewhere, you can make a lot of money doing that. So here's your applications with GIS from my point of view. And I know a lot of farmers and producers, they take yield estimates. That's what we do every year to say, hey, this is where our yield's at, this is what our treatments are doing, this is what's producing better than this treatment. If I can get you to look at the soybean and the corn yield formulas, this is what I've done for the past 2 years, and this is what we'll probably do this coming year. Corn came first, and your ears per acre are just a measurement. You go down the row and you measure a certain distance a row, you count your number of ears, and then you multiply it by the size of your total field. You do kernel rows per ear, and that is just picking a certain number of ears and counting around, counting down, figuring out how many kernels you have on. And what we did was we took 10 ear samples randomly per subplot, which was 32 subplots. So we had 320 total ears, and I took all of the grain off of them. I kept them within their subplots. I weighed them dry. I weighed them wet, then I weighed them dry, then I plugged them into this formula, and we got our yield estimate. Now that one wasn't too bad. It probably only took me a week or two. It really wasn't that bad. Last year was soybean, and that's when we got into a couple months of work. Now I realized I did it to myself. I wanted to be super accurate. So we had plants per acre, and it goes the same way that the corn or the ears per acre goes. You measure your row and just figure out how many plants per acre you have. And seeds per pod, depending on how tall your plants are, it's kind of well known. You can look it up and you can estimate that there's a certain number of seeds per pod. What I was interested in was pods per plant. So I decided I was going to count pods per plant, and I was going to take, within each subplot, I picked 3 different rows, and I took 10 samples per row. So that was 30 samples per subplot times 32 subplots. So you had 960 total plants. And I got it all together. When you're kind of doing research, you get excited with it and you get carried away. And I sat down in this greenhouse where all my plants were, and I was like, somebody has to count all these pods. So I counted and I counted and I counted, and I had a little bit of help, which is awesome. And we ended up having just over 46,000 pods counted. It took me a little over 2 months to do. It was very daunting, and that's why I put on here that with GIS and remote sensing, that your accuracy is probably higher and your efficiency is definitely higher, because your farmers and producers can't be out there counting all day. I know they don't take it as far as I did, but with your drone, like Jeremy was saying, it takes you 10 minutes to fly a field. Your accuracy, I can tell you for sure that although I don't think my error was super high, that I probably missed a couple pods. I probably dropped a couple pods. I was probably in there for 8 hours one day and maybe missed a plant. And after all that, we found out that there was not a significant difference. So I spent 2 months doing that and counted 46,000, and there wasn't a big difference in between it. So the one thing I want to point out, and my idea going forward, is the small differences, like I mentioned earlier, the small differences you find, even if it's not significant, if you apply it over a large farm or even 10 or 20 acres, that small difference equals money in a farmer's pocket. And the one way you can get a farmer to change the way they do something is give them money. If we're improving our soil quality and also making money at the same time, that's best case scenario. That's what I'm here to do. And I couldn't get out of here without talking about current research. I know there's some people from K-State watching online. I encourage you, if you run into either one of these graduate students, that you stop them and you ask them a question about their research. The only people they talk to about their research is myself and their supervisor. And I want them to get out there and start talking about it, start talking to people about it, even though they just got here in January. The more experience, the better, definitely speaking. Ganga is right down over here, and I will take you and show you her plots anytime. We also have a soil pit that was dug yesterday. I would love to show you that. And she is assessing the effect of different rates of biochar on soil physical properties. So I did a low rate of biochar in my research, and I was focused on chemical properties. She is doing different rates, which are much higher than what I did, and she is looking at water holding capacity. So if you're in a drought situation and your soil is holding more water because of biochar, then it's worth the money, it increases your yield. I'm not going to talk too much about it because I want you to ask her about it. And Ife is looking at, now I was told this is a tentative title, you may see a different one day, the ecosystem restoration and its drivers at the Daniel Boone National Forest of Kentucky. I don't know enough about this one to tell you specific details. Every time I talk to Ife about it, he teaches me something new, and it's cool to have that kind of relationship that he teaches me instead of me teaching him. We went there not too long ago. This tower is where all of his data comes from, and to get up there, it is about 15 minutes of the toughest driving up a mountain you could ever have. And every time I look at Ife's computer, he has millions of points of data from the Daniel Boone National Forest, and I'm excited to see what kind of graphs he gets out of it. So I encourage you to ask him a question, grab him, just ask him anything about it. And I'm going to end here with a quote that I really like, "A nation that destroys its soil destroys itself," by President Roosevelt. And I would be happy to answer any questions. Or you can grab me later and ask questions. I know lunch is coming soon. Thank you.
So for monitoring Jacob's project, we simply come out every other week here to the farm, and we have our multispectral drone we fly, and we fly the LiDAR. So there's several vegetation indices, and then trying to get an idea of what the structure looks like. So how deep the grass is, how close various things are, or whatever. We tell a story on our side, and then at some point, we're trying to translate that into the very metrics that they need to do their research. And then that's when we'll know if what we're doing is helping them or not. So thank you very much. Thank you for being here. I think that's lunchtime. You want to say a few words before?
I'd just like to make one announcement that I didn't make earlier. We're going to have our Small Farm Conference that we've had. This will be our 25th Small Farms Conference in November. Now, we've tried to do something. We've changed the dates. In the past, it's been Tuesday, Wednesday, and Thursday. This year, it's going to be Thursday, Friday, and Saturday. And that information will be coming out very shortly. Now, one last announcement before we have lunch. Dr. Bebe, would you stand up so everyone could see you? If you would be so kind, after you eat lunch, he is going to be doing a proposed research on skin cancer. And if you would just go by and see him just for about two minutes after you get through eating, he would greatly appreciate it. So at this time, we're going to go ahead and have our lunch. So at this time, you're dismissed. And we want to break for about 35 minutes. And then, Jeremy, where are we going to meet at? In here or back outside? Yeah, we're going to meet back here in about 35 minutes. Okay? Enjoy your lunch.
Sign your paperwork. You gotta. Let's see. Here was our. Good to go. All right. So let's see. I'm going to be talking a little bit, so similar topic as everybody else. So discussing a little bit about brome sage or broom sage, however you want to say it. So broom sage, and talk about sprayer sizes, so drone sprayer sizing. So it's been a little bit interesting. So two different topics, one focused on imagery, one focused on the spray application, but I think they're two very relevant topics, at least for a lot of producers in the state. So just the presentation outline, let's give a general background on some of the work I've done there at UK, then talk about brome sage and its background, then talk, dive into some of the sprayer drone aspects for applications in agriculture. And so some of the other work that I've done, so as far as utilizing drones, so we had some work that I've done with cattle and their interaction with drones, so looking at the cattle's heart rate and movement rate as far as when we fly drones close to them. So we had two different flight paths shown here, and so one being a grid pattern, the other one being a circular flight pattern. And so we flew these over cattle at about 30 feet, 25 to 30 feet above ground level. And one of the neat things was, so we had our heart rate monitor and our GPS collars on them, and so we saw no changes when we were flying at 30 feet above ground level, no changes as far as our heart rate or behavior for these cattle. So if this was all done with a Phantom 4. But if we introduced two drones to these cattle, we actually did see a change in heart rate for those first 2 weeks, and then after that, they were relatively calm. But we were able to also, with these drones, we introduced two drones, we were actually able to induce movement in cattle as well. Whereas if we're flying generally at 30 feet above ground level for pasture-raised cattle, we saw no response. So that was one aspect of my research, was looking at just the cattle's response to a drone. So we're utilizing these in animal agriculture. And here I have my graduate student, Gabriel, and our drone up there. So we're flying next or close by to one of our cattle here. So this is one of the ones we kind of did some more initial research with. And so she was able to, and we have our heart rate monitor on there, our collar on there as well to help for our GPS unit as well. And so we're able to just track for this cow and say that they're not negatively affected. At least some of them are not negatively affected, but for others there is an acclimation period by the presence of drones within a pasture. So that was one aspect of my research. Another one, we said we're looking at how much forage is in the field, or potentially we did some work with alfalfa, developed some correlations as far as what can we use that to estimate our height of our alfalfa, and then correlate that back to a crude protein, ADF, and NDF, so forage quality parameters, and just how much, and then also just how much is available within that field. So we get into brome sage, and so this is some work done with myself, Jimmy Hitting there at UK, and Prashanta, one of our graduate students. And so if you've seen brome sage, you probably see it right about October, November, and then on into the spring. But you see it's generally that orange-looking grass that you typically see, and it's the indicator in a lot of different pastures and hay fields of poor forage quality, or poor soil quality. And so just a little bit of background. So a little bit of background, it's a native perennial grass. It's a warm season, C4 grass. It's primarily in the southeast and potentially east and Midwest. But it is a weed. It is a weed in a lot of our pastures and hay fields. And for livestock, I've always been told, yes, that first field I showed where it had all that brown, yeah, we could have baled that. But it's highly indigestible, lowly palatable, and if they did, for some reason, eat it, it's not going to be utilized. It doesn't have a lot of digestibility within it. So it's almost, we'll always tell producers, it's pretty much 100% indigestible. They could eat it, but it's going to go right back out of them. It's not going to be a very valuable forage.
So there's a lot of issues with it. So I tell producers, you might bale this stuff up, but I don't think it's not necessarily much better than a snowball when we bale it. So it is a soil fertility indicator. So if our pH is below 6.4, if and it could be issues with our phosphorus or potassium, that can be indicated by the presence of brome sage, however you want to say it. I've heard it all different ways. But it can be a problem with overgrazing, a certain degree of overgrazing. If you get a little bit of overgrazing, and you have low soil quality, it'll be more likely to appear. However, if you have severe overgrazing, the cattle won't let it really get above this tall. If you have severe overgrazing, the cattle will eat it when it's still very small and somewhat palatable. They will eat it down. So it depends. But for the most part, you see a lot of patches of this. So what do we do to control broom sage? So they can be clipping. So in the late summer, maybe about this time of year, late fall, early fall, you go in there and clip. Another option would be to soil sample and fertilize. There's also, which I had these down here as maybe much more less desirable options, could be burning or non-selective herbicide. You go in there with a 2,4-D Roundup, just spray everything. However, what's going to grow back is most likely going to be brome sage, because if we already have soil quality issues, this brome sage will thrive in those conditions, so it's going to be most likely what's going to grow back. So a lot of times I say that, spraying it down with non-selective broad herbicide will not work. So, what is the challenge? We all kind of know the challenge. It's really the cost of fertilizer. So this graph here shows the red line would be our N, DAP, and your P would be your potash would be in the green there. This shows you kind of the general trend in fertilizer prices. And we've seen this, and I had a lot of producers, into 2020, going into 2021, and even in this past year, joking, well, if they didn't want me to buy fertilizer, they just should have said so. They didn't have to be mean about it. So, we had a lot of challenge, especially for the producers who are trying to, maybe use low input management. Maybe put down. It was very, very hard to justify the purchase of fertilizer the past couple of years, and so that has been one of the challenges. If you're doing low input management, where maybe we're not putting as much as needed, that can really affect your hay fields and even your pastures. So challenge was, we saw this in 2008, we saw it again in 2021, 2022. It's just that the cost of fertilizer went so high. And so we looked at a couple different fertilizer treatments. So this is a plot we were doing in Powell County. So we had a couple different fertilizer treatments for my N, P, and K. So we had some where we either applying, so the first zero would be either no nitrogen, or we were adding 180 pounds of nitrogen. We had our P2O2, so phosphorus we're adding, so we added 0 or 40 pounds, where we added either 180 or 360 pounds of potassium. And so we had a couple different fertilizer treatments, a couple different plots, 4 different plot ranges taking place. So how that field had been managed. So over the past 10 years, so the site we had chosen was a hay field, and that had been fertilized annually with 200 pounds of triple 19. And so that's 38 pounds of N, P2O2, O5, K2O. So when we actually soil tested our plot, we saw that it was 6.2 for our pH. We had about 72 pounds per acre of our phosphorus and 57 pounds per acre for our potassium. So our potassium, if we look at our results, it was in the extremely low category. It was extremely low for our potash. Our potash was extremely low, and the reason this was a challenge. So he'd annually put down triple 19. However, what it's uptaken, we're taking up way more potassium, potash than we are our phosphorus. So we're taking up 3 times more potassium or potash than we are our phosphorus. And so that was the main challenge anytime we have our fescue. So when we're moving 3.5 tons per acre or annually, we're taking up way more of our K2O than we are of our phosphorus. So that's kind of been one of the challenges. So even though he's fertilizing annually, it wasn't the right composition. So that was the main challenge. And so we conducted these flights. So what we did was we conducted flights. Initially, these flights were just conducted just to get a perspective of what's taking place at this location. Just get some shots. We'll get some good for extension publications, some extension articles, just to have what the site looks like. And so we did, these sites were harvested 3 times per year, and we did this from 2018 through 2020. We flew with the Phantom 4 V2, which has a 1-inch sensor, in essence. And we did about 80% overlap on all of our flights to stitch all those images together, similar to what they were talking about earlier. Oops, went a little too far there. Oh, there it goes. And so that was just showing that we were in Powell County. So we used a couple different visual indices. So we were just using that regular camera, but we just used different ways of analyzing the information. So we had greenleaf index, and we had a vary index as well, or vary as well. So there's different ways of looking at it, but it still used just whatever general parameters we can receive from a regular camera as well, just to get a general idea of how this could be producing. And so one of the things we saw was, I'm going to skip this one because they show generally the same trend. However, vary was a little better. But we could see where they were easily delineate themselves. So you can kind of see in the middle of the picture here where you can see in the middle where we had a couple of our plots where we had the no fertilizer plots. And so those plots, you can clearly see them in 2019, kind of towards the middle there in the red. There are, if you didn't have any fertilizer, we could clearly identify the brome sage that was in those plots. So they were more easily distinguished between our other ones. And similarly, we looked at different treatments. We saw a significant difference. So we didn't actually use any machine learning. We were just looking, can we quickly and easily see if there was a difference? And yes, we can see difference in which ones aggregated towards themselves. Where the high production, we generally saw those were grouped more together because they had a lower concentration of our brome sage, which we were trying to identify. And then we had our lower significance, so we saw a significant difference between those and our low treatments and even low phosphorus. So we saw that the addition of that phosphorus, or the potassium, was very important for some of those plots. And so this is from Jimmy Henning's work was, how did this affect our yields? And so this past year, that would be an investment. This would be an investment for a lot of producers. How did this addition of these nutrients, affect it? And we saw an increase in yield. So you got to remember that 2018, we had the warmest and wettest September on record. In 2019, we had the warmest and driest September on record. So that kind of affected our yields to some degree. It's, I think, on the higher end, which is why we saw 2019 being slightly lower than 2018 overall. But, we saw that with the addition of those nutrients, we are able to increase our yields. And in addition to that, so we saw a yield bump, and so I think for this upcoming year, we're already talking about maybe $40, $35, $40 potentially for a 4x5. This input of the fertilizer, you probably couldn't spend it fast enough this past spring, essentially. But think about our botanical composition. So how did our composition change? This is more work by Jimmy Henning. But again, we saw that if we didn't have any fertilization taking place, it's mostly that brome sage, which is going to be indigestible to the cattle and pretty much useless to us, or not as valuable to us. However, when we get to our higher fertilization levels, we can see that it definitely made a difference and that we can be more effective as far as utilizing this as a forage resource for our cattle and other animals. So it definitely makes a difference. Some of our future work, we're going to take that and get some more correlations to our botanical composition, work to get a better yield estimation, and then do it over time. We just evaluated these plots just only in October. So I think our next goal would be to evaluate it throughout the year with these same plots. And then also use some machine learning as well. And so you see this plot here. So it's a different area here. And we see there's still a fair amount of brome sage in this one. And so we could go out there and fly and try to figure out, what's the relative amount of brome sage in this pasture, give or take, a certain percentage. However, in my opinion, I'm being a little bit cynical, but, if we have to ask the question of how much brome sage do we have out there, we already kind of know the answer of what we need to do. And in that case, I'm suggesting that we go work with our county agent, get some soil samples taken out there, and then kind of apply as economically as economically as we can, apply whatever nutrients that are prescribed by the county agent. So my recommendation would be, if we think we have a problem, maybe don't necessarily have to fly. We could fly and show you how bad it is, but really maybe go out there, take a soil sample. If we see this, take some soil samples, then apply nutrients as prescribed. As far as, so I'm going to switch gears here. So that was for our broom sage. So now I'm just talking about sprayer drone sizing. So a little bit changing gears here, but we got a new sprayer drone this past June, so that's kind of been part of my focus. And so the one we have at Ag Engineering is actually on the, I guess, if you're looking at your right. And so what we see here is going to be, it's a much bigger drone, so that's a T40 next to a T10, which actually can only carry 8 liters. So I'm going to talk a little bit about the difference between the two and why, it's properly sizing would be important. And so for, some background for selecting our spray system, we have 3 different options. We either have a ground-based sprayer, plane, or helicopter, or we can have pretty much a drone. And so a lot of it will depend on a lot of little characteristics like field characteristics, crop maturity, and weather will be impacting. But for ground-based sprayers, you can spend upwards of $300,000 easily on a ground-based sprayer. It gives you the lowest cost per acre. You can do a relatively moderate capacity, so you can hit a lot of acres. You hit a fair amount of acres, but the disadvantage is it's going to have soil compaction taking place. You won't be able to get out there at sometimes we need to. A lot of times we see challenges, especially with maybe wheat. Getting out there, it could be rainy conditions in late May, early June. Those are kind of be expected. So that could be an issue. There's crop damage. So with soybeans, you're running across there, even some wheat, we're expecting we lose, maybe if we run that equipment across there, we're assuming that you may lose upwards to a bushel. It depends on the study that you're looking at, but you could lose up to a bushel per acre potentially. So it depends. It depends on the crop and the timing. And there's limitations. It's going to be limited by trees, power lines, waterways, irregularly shaped fields. So everything you expect to have in Kentucky here. Whereas if you have a human-occupied aerial sprayer, so those would be what I call planes and helicopters, a lot of times for them to even think about showing up, they want to have at least 800 acres. Together, maybe you and your neighbors, they want to have at least 800 acres for them to think about showing up. So a lot of times we're trying to figure out what do they, and you're operating on their schedule. So you're pretty much relying 100% them on when they feel like showing up or when they get their other jobs done. So, but their advantage is they can be very high capacity when they do show up. They take care of a lot of acres very quickly. But again, they're limited on, similar to the other one, trees, power lines, irregular shaped fields, don't have to worry about waterways per se. But sometimes there's zero or limited availability of these planes and helicopters in certain parts of the state. So the drone sprayer, a lot of producers who have used drone sprayers, the main reason they switched was primarily based on timing. So timing was the main reason that a lot of these producers switched. There's no limitations based on soil conditions, so you can fly, even if the ground is a little wet, you can still get out there and fly. No limitations really based upon trees. You're cognizant of them. It has collision avoidance system. It won't 100% prevent you from colliding with the tree, but it should limit the amount of times that should happen. You can also limit, potentially, as long as you plan your flight correctly the first time, limit your interaction with power lines. So you can hopefully avoid your power lines. Waterways aren't a problem. You just fly over your waterways. Anytime you have irregular shaped fields, they're not really an issue with this because you can just fly and then fly out of that field fairly easily. So regular shaped fields aren't a problem. Spot spraying could be an option, and there have been, maybe not with the biggest drone, but some of the smaller ones, you can use them for fence line applications of herbicide. So there's options with that as well. The disadvantage is you're going to spend a lot of time refilling batteries and refilling your tank and changing batteries. So you're going to spend a lot of time doing that, and there's probably the lowest capacity on an acres per hour basis, but you can offset that by you just get more drones, potentially. If you really have a large number of acres, you just get more drones to accommodate that acreage. And so, you do a similar flight path that you would with any of your other drones. It's going to be a grid pattern, and you can modify it. You can set up, if I have certain obstacles in my field, I can set up areas of exclusion where I don't want to go and areas where I can fly. So there's a lot of different options available for setting up flight plans for your fields. Or you could potentially do spot spraying if that's something where you could save some chemical cost, but you have to fly ahead of time and identify areas where there's issues potentially. As far as regulations, so it's the same license you need to fly, so you still need your Part 107 license, so that means you're passing the FAA knowledge test. However, in either case, your sprayer drone must be registered with the Federal Aviation Administration, so it's $5 and it's good for 3 years. The knowledge test is $175, and most everybody, over 90% of people do pass the test because you take it seriously. And as far as airspace is concerned, there's certain areas where you can and can't fly. There's apps such as Before You Fly that allow you to determine if this airspace you're flying is going to be suitable or not. And so this shows the western half of Kentucky. So I guess up there at the top there is Louisville. And just gives you an idea of, there's all the non-towered airports, but the non-towered airports on the province, mainly just the towered airports. And there's all certain areas, parts of the state, so we're next to the Bluegrass Army Depot. There are certain areas over there we obviously can't fly. Fort Knox obviously can't fly. But otherwise, for the most part, we're generally should be able to fly and just have to be cognizant of manned aircraft, potentially if there's an airport nearby. But these should be operating within 20 feet above ground level for the most part if we're doing spraying applications, 20 to 40 feet above ground level within that for the most part. So I mentioned the knowledge test, so it's Part 107 knowledge test. 90% of people pass it. There's greater than 50,000 commercial drone pilots, so you have to be 14 years or older to actually take the test. And you have to maintain, the way the current laws are currently written, you maintain line of sight with these drones. And there are certain aspects of the weather we have to also be cognizant of. But there's a couple different topics that are listed there, and it's 60 questions. You just have to get 70% or greater to pass this exam. And in addition to that, if we're doing our aircraft, so you may mention that they've been imaging since the 1960s. A lot of these is the land here in the U.S. As far as spraying, it's also kind of been since the 1960s. So a lot of the rules and regulations for application of chemicals, or the economic poisons they sometimes call them, or their official definition, is they were done in the 1960s, so a lot of the rules for drones, we have to get exemptions. We have to get exemptions for flying drones. We have this agricultural aircraft operator certificate, which we have to obtain, but we have to also get exemptions to it because certain aspects don't apply to drones. And size does matter for sprayer drones, so there's ones that are under 55 pounds and ones that are over 55 pounds, and so there's two different sets of regulations that we have to abide by when we're utilizing drones. And so here's our common commercial tank sizes for drones. So anywhere from 8 liters to 72 liters. And that's generally how they size the drones. Is typically when you see a T10 or T20, it's basically on liters, except for the T10, which is actually 8 liters. But everything else generally is a T40 is going to be 40 liters, T30, 30 liters. It depends on the manufacturer, but generally they size them in liters. And so your petitions for exemptions, so you need to get at least this 120 days prior to commencing your spraying applications. And so there's just sections that aren't applicable to your sprayer drones. And a lot of times I suggest producers just get a consultant to do this part for you. It's a lot easier for them. They've seen it before and they can just walk through the process easier. So for certain of these, that if you're carrying a hazardous material, so if we're doing a spraying drone, a hazardous material could be any chemical you could have. So you have a smaller sprayer drone, you have to get that exemption. For your larger sprayer drones, you don't have to worry about that aspect. However, there's still more because we're operating under Part 91, you have to get other exemptions. So there's a certain list of exemptions that you have to get for each size of drone that you have to also think about. There's also the operation of multiple drones. So technically, one operator, at least for the smaller ones, could operate multiple of the smaller drones. And there is a waiver for that. And you have to almost have one person actually there watching out to make sure you're operating safely as well. One visual observer. So when we're conducting our spraying applications, you have two primary inputs. If we're inputting our time, if we're doing this as a business or as a farmer, it's going to be money or time. And so if I'm sizing my drone, I'm taking those two aspects into consideration. And so we do have, and I'll try to get this at some point, maybe after my presentation, I'll have a couple cards I can give out. We have a sprayer drone cost summary decision aid. So we have a decision aid where you can enter the information for your different types of sizes of drones and then be able to calculate from there what is the cost. If you have a certain, like a T30 or T40, what's the difference? You can input that into the information, into this, and determine what would be your cost per acre for flying. Some of the stuff we have to think about, as well as, what's the minimum requirements to fly? So I need a drone and charger, a drone and control station, a charging unit. So it used to be in batteries, so the batteries only lasted, you need about 8 batteries. You used to have 8 batteries to operate for a day. Now with the and they took about an hour to charge per battery. Now with the higher charge rate of some of these newer chargers, we can charge a battery within about 10 minutes. And so now we only need 3 batteries to potentially get us through a day. So that's make us a little more efficient. We do need a generator with ample amperage and voltage to supply the current needed, to supply the power needed, for our drone. And then if you need chemical tanks, fill station, propellers, extra propellers, landing gear, stuff you think are consumables, will also be, and a fill station, a tank, and a pump system. And any personal protective. And so if you're operating with these chemicals, you will need some PPE, whatever is required, depending upon the chemical. And then a lot of times I see producers to maintain visual line of sight, and you kind of see in this picture here where they have the umbrella up there, so that's also important. So you're usually applying these in late July, early August, and so you generally have like a 3-week to 60-day window if you're a service provider. But they're up there on top of that box truck, and that's where they're maintaining visual line of sight as they're flying around in those cornfields. So you have to maintain visual line of sight, and then one guy's on the ground refilling the tank. And so a fan is important. You have to have a shade is important. Maybe insect repellent. So stuff you wouldn't think about the first time, but you definitely think about the second time you go out there. So little things. And then software is typically included with the drone. They're going to be different for each one. And there's little differences in specification. I'll talk about that here in a second. I'm going to skip a couple of slides, and we're going to jump into some of our cost metrics. So I've plugged in some of that metrics of commercially available drones. And so there's cost per flight. We're not really concerned about the cost per flight because there's going to be a lot of flights. If we're doing 1,000 acres, it's a lot of flights depending on our drone size. Cost per acre is going to be more important. Cost per hour will vary, but depending, again, on our drone size and the amount we're actually applying. And so this is just, I was running through here an example of calculations, but I've already have it summarized here, so let's jump down to that. All right, so two sizes. That's 2 sizes, different sizes of drones. They can be bigger or smaller than that. However, okay, so the drone specifications. I want to jump in this for a second. So we increase our tank size, we're going to increase our operational efficiency. We increase actually the acre sprayed per hour because we don't have to land near as often, spend that time refilling and changing batteries. Increase our spray width, we can also increase the number of acres that we're spraying as well. Increase our flight speed, we're going to increase what we can spray, increase our flow rate of our pump sizing. We'll also increase the acre sprayed per hour. And then if we increase our spray volume, so instead of spraying 2 gallons per acre, I'm spraying 5 gallons of chemical mixture per acre, it's actually going to decrease our overall rate, the acres that we can spray per hour. So I'm putting a higher volume on, it's going to decrease the rate at which I can spray. And we'll go into some more of that here in detail. So as far as number of refills, what we can see here is even at 2 gallons or 3 gallons per acre, if we have that, from the left to right, or from left to right there, you have the 8 going all the way up to 72 liter drones. So these are commercially available. The 20 liter is no longer commercially available, but these are commercially available drone sizes. And so we have a lot of refills with the smallest drones, as opposed to if we get larger, we're spending less time refilling those drones. So that could be something to think about. How many times we got to land that, spend a minute or two, it adds up very quickly per flight. So if we're spending a minute or 2 per flight and have to refill it 1,000 times, that's adding up fairly quickly. And so looking at the different drone sizes. So in this case, for my analysis, looked at the 8, the T10 essentially, the 8 liter, the 30 liter, 40 liter, and 72 liter drone. So that'd be the one that Helio has. Helio has, I think, the biggest drone currently available on the market. And so the maximum flow rate, is actually higher with some of the smaller drones, potentially, than it is with the bigger ones. But the effective speed, operating speed, we can go much faster with some of our bigger drones. And the effective spray width is also much larger with our bigger drones. And so, but there is, coming with that bigger drone is also that bigger cost. So we see that we go from about $22,000 baseline to about $78,000 baseline. And the $11,350, that's just assuming you got to get a small trailer, a tank, a generator, and some other just miscellaneous supplies that we got to have. And insurance is going to be for a farmer, I assume it to be about $2,500 per annually. But for a service provider, if you're doing it as a business, you're going to be spending about $4,000. And then looking at, thinking about different spray volumes of 2, 3, 4, 5 gallons per acre as far as our spray volume. So as far as my allocation of my flight time, so with my flight planning and setup, I assumed about a tenth of a minute on just flight planning and setup. I assumed 4 minute split down between my takeoff, ferrying, and landing. So just going out in the field, so 2 minutes out, 2 minutes back, and landing. And then time spent between flights was about 2 minutes. That could be, if you're a service provider, sometimes that could be faster, but I just assumed a baseline of 2 minutes. And then with my actual US spraying time, it varies with the parameters of the drone, and the visual observer time, I had that varied, same as the pilot in command. And so as far as our spray volume, drone size, and acres sprayed per hour, we see that as we go from 8 going down, we increase in our capacity of what we can actually accomplish per hour as far as spraying. So we can get almost up to 50, going from 7 to 50. But as we increase that spray volume, we're seeing that decrease going from 2 gallons per acre to 5 gallons per acre. We can definitely see a distinct drop-off in what we're able to cover as far as spraying. And so for farmers, so thinking about farmers, looking at my cost per acre, so this is just a general, it's a general breakdown, some different colors, but just assume it's like a stoplight. Green is good, yellow is okay-ish, and then red would be bad. And so it's either bad for cost per acre, it's going to be in the red zone for either it's too high, or it's going to be taking too long. So I assume that we had a 3-week window potentially. So if it was taking greater than 3 weeks, 3 or 4 weeks, it got into the red zone, or 4 weeks, it was in the red, because it might be at the limit for a farmer to achieve what they need to. It depends on their planting dates and other aspects, but there's, have a large number of acreage, what can be done in 3 weeks. What is interesting about this is that we see that even at, and this is for gallons per acre, so if we have the topmost rows are at 2 gallons per acre. The difference in drone size is we see that even the smallest drone, it only makes sense at around 1,000 acres. And generally for applying, spraying at 2 gallons per acre, having less than 1,000 acres, if you're spraying anything less than 1,000 acres, it might make more sense to hire that work done than try to do it yourself if you're a farmer. Because usually you get about $15 per acre for a lot of these farmers service providers will charge you about $15 per acre. So we want to be below that cost, ideally. And so really, it almost makes more sense for the moderately sized drones, depending on your farm size, the moderately sized drones make a little more sense, potentially. And then as we increase that spray volume, the minimum size that we need, drops down to, as far as acreage-wise, it's going to be about 500 acres to make this economically viable. However, that's assuming our cost is going to increase, and I'll talk about that a little bit when we talk about our service providers. But this assumes that we're doing, if it's yellow, it's going to be less than 4 weeks. If it's green, we're less than 3 weeks. As far as our numbers of 40-hour work weeks that it's taking. And so what's the calculated range? So the calculated range for each size of drone, so we're going from 8, 30, 40, which are moderately sized, and the 72, which is the largest size. What's the minimum number of acres? So as we increase our number of acres sprayed, we spread that our fixed cost over more and more acres. So for this to make sense, to get below $15 per acre at 2 gallons per acre, we really have to almost have 1,100 acres for that smallest size drone to make sense. We get to the biggest one, we almost need at least 2,000 acres for it to make sense. But with the biggest one, we can do almost up to 6,000 acres within a 3-week period, as opposed to the smallest one, we're doing almost 900 acres. So it's really close there. It almost makes more sense to use the T30 if we have around 1,000 acres. So it almost makes that moderately sized drones make a little more sense in that aspect. So there is an appropriate size for some of these farms. So it depends on your acreage and how much you have to spray within a certain time window. But depending on what it is and how much you're actually spraying, a moderately sized drone might make a lot more sense for a lot of these farmers. As far as we have to think, well, what if I used a bunch of smaller drones as opposed to one of my bigger drones? So let's say we had 4 8-liter drones versus one 40-liter drone. How would that comparison work? How would that perform? And think about those. If we had the 4 8-liter drones, they're going to cost you about $14 an acre, as opposed to if we had the one T40, which is appropriately sized for that 3,000 acres, it's about $6.50 per acre. So it's a lot more economically viable to have the appropriately sized drones. You cover a larger area more efficiently, and there's probably going to be less mistakes because you streamlined your management. You're not worrying about each individual drone. You just have one to worry about. So I think it's reduced chances of, logistical challenges. So it makes a lot more sense to do it that way as opposed to getting 4 of the smaller ones. So from an economic standpoint, a per acre basis, we're trying to cover 3,000 acres. Instead of having 4 8-liter drones, just get one big appropriately sized drone, potentially. And so for sprayer service providers, so if I'm a sprayer service provider, so that was for farmers. If I'm thinking about sprayer service providers, your main income generation is going to be for spraying corn fungicide. So that's what I'm thinking about. I have a 3-week to 60-day window to make my money, or generate most of my income. And so that's going to be your bread and butter. That's where you make your money, because they also have some new effective products, relatively new effective products. So, that's where my main focus. If I want to diversify from that, I'm thinking about spreading seed, frost seeding, maybe some clover in February, March. You think of different ways to maybe integrate myself into weed applications in May and June. July and August, I'm just focused on corn fungicide. Then after that, could be looking at cover crops, could be thinking soybeans, and maybe even some herbicide applications taking place throughout the year. So, over that 3-week period, so we look at our per acre income. So if we have, for each one of those drone sizes, what can be sprayed within 3 weeks? So based upon the numbers I kind of initially talked about, in each case, I'm assuming that this is at 2 gallons per acre. This is at 2 gallons per acre. We're making your charge of $15 per acre. So flat fee. Your expenses for each one are going to be drastically different. So for the smallest one, it's 13. Then as we get larger, it generally, for the most part, decreases. Now, even though it is slightly higher, like the 72 is slightly higher than the 40, we can cover so much more acres with the biggest drone that our net income is still going to be much higher with the biggest drone. Also, that hopefully on the next slide of why that makes sense. So for these, a lot of times I think it makes more sense to really go big or go home. If you're a service provider for these, it's almost go big or go home. Go for the biggest drone that you can get, or the biggest drone that you're most comfortable with operating. And so because you can cover so many more acres in that same time period with the biggest drone, we weren't making as much per acre, but we covered so many more acres that made up for it. So over that 3-week period, excluding taxes, excluding some of the travel aspects, if you were busy 40 hours per week spraying, you could be looking at up to about $61,000 there, as opposed to with the T40 and T30, as you reduce that size, we reduce the net income potentially. So I think there's a lot of opportunities for service providers, at least within the state, to take advantage of some of these numbers here. So relationship between drone size and, we kind of saw a similar graph to this earlier, but what could we actually spray within 3 weeks? So I had what we could do at 2 gallons per acre. Now we include 3, 4, and 5 gallons per acre. As we increase our acreage, again, we're seeing that what we can spray within that 3-week period definitely decreases. So how do we take care of that? How do we adjust that? So we need to maintain, a lot of times what these producers will do is to maintain a similar level of income will increase the price that they're charging per acre. So at 2 gallons per acre, a lot of these producers are going to be charging $15 per acre flat fee. If you want 3 gallons per acre sprayed, they're going to want at least $20 or $22, depending on how their budget's set up. And so as you increase the spray volume requested to these service providers, they're going to have to maintain a similar level of income, they'd have to increase it accordingly. So during that peak time, if you really, really wanted 5 gallons per acre, I can't cover near as many acres, but I can say, well, I can charge you $36 per acre. In essence, if I want to maintain the same level of income that I have when I'm spraying at 2 gallons per acre. So there are trade-offs, and so if you want the service provider to spray more, they're probably going to have to charge you, spray more volume, they're probably going to have to charge you more. So the main takeaway, for farmers, we got to think about our spray volume. Think about your acreage and the time window. So for this to make sense, at 2 gallons per acre, we need at least 1,000 acres for this to make sense. At least 1,000 acres for this to make sense and purchase our own. If you're spraying high volumes, it makes sense about like 5 gallons per acre, 4 or 5 gallons per acre. You can have it penciled out about 500 acres for this to make sense to get a sprayer drone. For your sprayer service providers, clear message, go big or go home. Get the biggest drone that you're comfortable with operating. And so you can generate the most income for your operation. And we do have 2 extension publications I want to mention. So we have the one where I talk about the general considerations and requirements for drone spraying. So AEN 171 and then AEN 172. So helping determine all these cost structures. We have an Excel sheet essentially that you can input some of your, if you have a certain drone that you want, you can input your numbers there and see your potential cost of how it could compare to maybe some of the other drones available on the market. So with that, are there any questions? Yeah. So the question was, what is the average size of the farm? Here in Kentucky, it would depend. So if you're talking about beef cattle farms, they'd be about 50 acres. If you're talking your grain farmers, I know they can get fairly large. But there is a fair distribution of corn grown throughout the state. So I think it might be more options available for service providers, I think, throughout the state as opposed to farmers getting their own. There are a lot of farmers who have, throughout the state, who have these. But I think they're more so in the west, even West Kentucky, even though they have the big flat square fields. Actually, some of these sprayer drones make sense. Here in central Kentucky, where it makes a lot more sense is where we have that regular shaped fields, waterways, trees. It's a lot easier to get a drone in there as opposed to any other equipment. Let's see here. Anybody else? All right, thank you.
Let's give Dr. Jackson another hand. Thank you, Dr. Jackson. Next, we will have Dr. Chiyuwa from Kentucky State University will be speaking with us on monitoring soybean yield and plant quality using aerial field typing.
Thank you. Good afternoon, all. So today I'm here to talk about one of the field research experiments which is undergoing here at KSU farm. And we have been using drone, and we have been flying drone every 2 to 3 weeks interval in that farm. So, and also like I think so Jeremy is also one of the like project member of that team, and so he's going to share some of the images of that field, and also he's going to share some of the results of that experiments. So we thought it would be better if we provide a little bit more information about that field research activities. So that's why I am here. So the research was funded from USDA NIFA. So we got 600,000 grant to conduct that field research experiment, which is on soybean. So as many of you know, like soybean is the commonly used animal feed in most of the poultry and livestock farm. in US and also in many other countries around the world. And so a little bit background for conducting this study. So what is happening in soybean in the US, right? The yield is increasing. So over time, the soybean yield is increasing, so that is good news because we have been developing that improved varieties. We have been identifying improved cropping system, crop cultivation practices. So that's why the yield is increasing. But at the same time, what is also happening that the seed protein concentration is decreasing. So the yield is increasing, but seed protein concentration is decreasing. So that's why if we compare seed protein concentration in the cultivars that is currently growing compared to the cultivars that we used to grow like for let's say like 5 years back or 10 years back, then the seed protein concentration in the modern soybean cultivars is very low. So that is actually has become a concern because the seed protein concentration is one of the like very important factor that determines the quality of the soybean meal, the quality of animal feed. So that's why there is an like urgent, need to increase seed protein concentration because what is happening like, the currently produced US soybean meal has struggled to meet the requirement for the high quality animal feed. That's why there is a need to increase seed protein concentration, and recent studies like have suggested that there is nitrogen limitation during seed filling phase in soybean. So that is the main reason for decreased seed protein concentration in these modern high yielding soybean cultivars. So there are like some research has suggested, including my previous research at University of Kentucky. We found that there is a nitrogen limitation during seed filling phase in soybean. Because of that, there is like decreased seed protein concentration in modern soybean cultivars. So that's why in this field research experiment, we are testing two different treatments. The first one is late season nitrogen fertilizer. So to address that nitrogen limitation during seed filling phase, we are testing this late season nitrogen fertilizer application, and also we are also testing biochar application. So biochar, as many of you also know, it is one of the very widely used soil amendment to improve soil structure and fertility. But the reason I am using biochar in this experiment is that in previous studies, biochar has also been found helpful in improving soybean root growth, soybean nodulation, microbial biomass. So all these factors, they are very important to improve soybean biological nitrogen fixing ability. So that's why we are using biochar in this experiment to see if it can improve soybean nitrogen fixing ability and ultimately soybean seed protein concentration and seed quality. So these are the two experiments that we are testing in that field research that is currently undergoing here at KSU Farm. And so this is the experimental design of that field study. So as I just mentioned, there are two different level of treatments. The first one is biochar, and so we have 4 different blocks. So the green color represents the blocks that received biochar, and the yellow color, the 2 blocks that did not receive biochar. And we have another level of treatment, which is nitrogen fertilization. And as you can see, there are different color represent different rate of late season nitrogen fertilizer. For example, as you can see, the light yellow represents no nitrogen without biochar treatment, 40 kg, 80 kg, 120 kg nitrogen per hectare without biochar. And similarly, the green color, the light blue represents 0, no nitrogen, and 120 kg kg nitrogen per hectare with dark blue or green color. So this is the experimental design of that experiment, and we are using 2 different maturity group 2 cultivars, one maturity group 2 early maturing cultivar, and another maturity group 4 full season cultivars late maturing cultivars. And we are also using 2 non-nodulating cultivar as a reference crop to quantify biological nitrogen fixation in soybean. So the main goal of that experiment is to quantify the effect of late season nitrogen fertilization and biochar application to see if it can improve soybean seed protein concentration and meal quality. So that is the main goal, main objective of that experiment. So similarly, we have like another experiment where we are using aerial phenotyping, where we are using drone to see if we can use drone to assess soybean growth, physiology, and yield. So Jeremy is taking a lead in that for that objective, and in that objective, what we are doing that we are collecting aerial images using drone, or you can say UAV, every 2 to 3 weeks interval, fitted with different cameras, RGB cameras, multispectral cameras, thermal cameras, and LiDAR sensors. So he has been flying drone every like 2 to 3 intervals in that field. And similarly, what we are also doing, we are collecting all those manual measurement at every like 2 to 3 interval. On the same week where drone, like Jeremy is flying drone, we are collecting plant height, leaf area index, leaf chlorophyll content, photosynthetic efficiency, plant biomass, and grain yield. And so the objective was to identify the most effective sensors and indices to measure each of those traits and also the yield prediction in soybean. So that is the like objective of these activities. So let me give you an example. For example, let's say plant height. So we have been collecting plant height, we have like plot level plant height data, right? So Jeremy has been flying drone. So from the aerial images, let's say from aerial like RGB images, he's going to extract plant height. And also from LiDAR sensor, he's going to extract plant height from that plot. And we have the manual measurement in that plot. So the idea is to see the association, see the correlation between the plant height data that he's going to extract from RGB images and also from LiDAR images, and to see its correlation with the manual measurement, and to see like which one is more effective in estimating plant height in soybean. And not only the sensors, also like we have been collecting like aerial images like every 2 to 3 intervals, right? 2 weeks intervals, and also to see like which time is like more effective in estimating plant height in soybean using aerial phenotyping. So the idea is to identify the most effective sensors and also the most effective time window to estimate, to predict plant height in soybean. So similarly, for all other traits, we're going to see the association, we're going to see the correlation, and to see like the most effective aerial images, most effective indices to measure all those traits, such as like leaf area index, chlorophyll content, like plant photosynthetic efficiency, biomass, and grain yield. So that is the whole like idea of that objective. So I believe like Jeremy is going to share some of the aerial images and some of the results of that experiments. So I'm going to turn it over to Jeremy. And before that, I'll take if you have any questions about the experimental design, the objective of that experiment, and any other questions you may have. If not, then I'll turn it over to the Jeremy, so he's going to share the images, and definitely I'll be around. Like if you have any questions, I'll be here to address those queries. So yeah.
Yeah, and just in case it wasn't clear, so we had Jacob up here earlier talking, and he's back on this back field. So this year for that field was the field from last year where they started doing what he was just talking about. So I've already shown you a bunch of examples of the types of products that we're making. We had multiple examples where we were extracting vegetation index, and that's some of what he was sharing. And we've talked about height multiple times. So from our regular, and your phone can do this too, just those overlapping pictures, you can extract out fully the three-dimensional nature of what you took a picture of. So that's how Tesla drives now, right? It just takes a picture and it estimates depth, right? It decides where it needs to go. So photogrammetry is extracting out the 3D nature from an image, right? So LiDAR gives you this much more precisely, but LiDAR is very expensive. This is very cheap, So really one of the questions implied in this is, do we have to have the latest and greatest in measuring equipment, or can we get by with stuff that's piled up, literally, to do the same thing? So we're not disconnected totally from what a farmer can actually access, because we've shown you some really expensive equipment, but we're also using dirt cheap stuff too to get the same products. These are just pictures from the field back here. This is on actually the north end, but these are from last year. These are the plots, how they were laid out, and basically every little square is an observation, a square meter observation, and we're just aggregating the pixels that fall in it. And so here it's plant height, so just as the plants are growing up, you know, they're just filling in from white to full green, and you're just tracking that over time. Just tracking that over time. And then this is, again, a statistical representation of what you see there, because he has that secondary question. These are the performance of all the blocks, and one of the implied questions in this project is it necessary to be out there flying every 2 weeks, or can you fly once or twice in the really key part of the growing season to get the same information? So maybe it's not necessary to fly bi-weekly. Maybe you can just fly once. Just make sure you fly at the correct time to basically get the same information. And I won't bore you with all these, but this is literally every individual plot, the performance of it over time. Anyway, so then the next steps, of course, will be just correlating the information we got from the imagery here and with whatever he ultimately comes together. It'd be the same for Jacobs and the same for Ms. Wallings that we talked to earlier for aquaculture. All right, so that's it for the presentations. The last thing that we have today, we have some of our equipment here today if you want to have a look at it. We have a couple of multispectral drones. We have the big LiDAR drone, and we have one of the spray drones that are set up back there. So if somebody wants to fly a drone, we can put you behind the wheel of it, or if you just want to look and take pictures, you can do that too. Any final questions for any of the presentation material? All right. Well, thank you all very much, and thank you for coming.